In the year 2085, humanity embarked on a mission that would forever change the course of our species. The most brilliant minds on Earth had converged on a singular goal to make Titan, Saturn's largest moon, a world capable of sustaining life. The Titan Terraforming Initiative was not just another exploration, it marked a new chapter in human history, embodying our drive for innovation, survival, and the expansion of life beyond Earth. At the heart of this ambitious undertaking was the Aurora Ascendant, a cutting-edge interplanetary vessel equipped with revolutionary technology, including nuclear fusion propulsion, gravity manipulation systems, and a fleet of autonomous robots that would carry out the intricate task of transforming Titan's environment. The Aurora Ascendant was designed to be more than just a spaceship. It was a self-sustaining ecosystem, a mobile laboratory that housed all the necessary tools to begin Titan's transformation. On a brisk morning at the Kennedy Orbital Launch Facility, the countdown began. After years of rigorous testing and simulations, the moment had arrived. The launch platform trembled as the Aurora Ascendant was propelled into the sky by a powerful nuclear-powered catapult. Its fusion-powered engines flared to life, casting a glow brighter than the auroras at Earth's poles. Within minutes, the vessel had soared beyond Earth's atmosphere, leaving behind a symbolic trail as humanity bid its final farewell to its home planet. Once Earth's gravitational influence was no longer a factor, the Aurora Ascendant entered a nearly 2-year journey through deep space. During this time, the ship's systems operated autonomously, with the onboard AI, known as Ether, overseeing everything from propulsion to life support. Ether continually adjusted the ship's trajectory to optimize fuel use and maintain the mission's schedule. The crew lived in specialized habitats, each designed to simulate Earth's environment with rotating modules that mimicked day and night cycles. The habitats were equipped with interactive holographic displays, aeroponic gardens, and shared spaces where scientists, engineers, and artists collaborated. In one area, astrobiologists speculated on Titan's potential for life, while in another, engineers fine-tuned protocols for deploying the terraforming robots on the moon's surface. The passage of time was measured by milestones. Every 100 million kilometers traveled every successful test of terraforming systems and every simulated emergency drill. As the Aurora Ascendant passed Mars and Jupiter, the crew marveled at the view through the ship's panoramic windows, observing distant stars and spinning planets in the cold silence of space. After 2 years of careful travel, the Aurora Ascendant began its approach to Saturn. A series of orbital adjustments ensured the spacecraft's entry into Titan's orbit would be precise. Titan, with its thick nitrogen atmosphere and expansive methane lakes, presented a challenge to the terraforming mission. Its surface, perpetually covered in shadow, awaited the warmth and atmosphere that the Aurora Ascendant would bring. In the final weeks before entering Titan's orbit, the command center, called the Helios Nexus, was in full operational mode. The crew performed numerous simulations, preparing for the complex descent of robotic pods that would be deployed from the main ship. These pods carried the necessary tools to initiate the terraforming process, including reactors to release greenhouse gases, orbital mirrors to redirect sunlight, and bioreactors containing engineered microbes capable of converting Titan's raw materials into breathable air. As the moment for Titan's orbit insertion arrived, the excitement was palpable. With precise coordination, the Aurora Ascendant's engines fired, and Titan's massive form appeared on the forward screens. The vessel decelerated, settling into a stable orbit 1,200 kilometers above the moon's surface. The crew watched as the journey that had started so long ago entered its next phase, the beginning of Titan's transformation. The terraforming mission commenced immediately after reaching orbit. Automated landing pods detached from the Aurora Ascendant and began their descent into Titan's thick methane-rich atmosphere. The pod's heat shields glowed as they cut through the dense clouds. Equipped with an array of sensors and guidance systems, each pod was directed to carefully selected landing sites, chosen for their geological diversity and significance in the terraforming effort. At each landing site, a specialized terraforming unit, codenamed Prometheus, unfurled its components. Prometheus units were designed to perform a suite of tasks, vaporizing portions of the icy surface, releasing controlled amounts of super greenhouse gases and dispersing engineered aerosols that would gradually alter the moon's albedo. The initial target was a vast frozen plain near Titan's equator, where ancient cryovolcanic channels hinted at the possibility of subsurface reservoirs of water and ammonia. By introducing a calibrated mix of carbon dioxide, water vapor and trace elements, the Prometheus units aimed to initiate a warming cycle that would melt pockets of ice and set off a chain reaction of atmospheric transformation. Control of the terraforming process was maintained through a network of orbital relays and ground-based communication nodes, which continuously transmitted data back to the Helios nexus. Sophisticated simulations modeled the expected outcomes of each intervention: temperature gradients, pressure differentials, and the evolving chemical composition of Titan's air. Each adjustment was made incrementally, respecting the delicate balance required to avoid runaway climate effects that could turn Titan into a hostile environment far worse than its current state. Within weeks of deploying the terraforming units, sensors began to register subtle changes in Titan's atmosphere. Infrared imaging from the Aurora Ascendant revealed areas of unexpected thermal activity, hotspots where the Prometheus reactors were successfully melting thin layers of surface ice. Automated drones, released from the orbiting mothership, conducted close-up surveys of these regions, transmitting high-definition images and spectral data to mission control. At one particular site near the equator, the temperature began to rise by nearly 15 degrees Celsius over a 48-hour period. The engineered aerosols were reacting with Titan's naturally occurring hydrocarbons, forming a rudimentary greenhouse layer that trapped more heat than anticipated. This spontaneous synergy between human technology and Titan's native chemistry was both thrilling and sobering. It signified the first tangible step toward a habitable environment, yet it also underscored the immense responsibility that now rested on the shoulders of every mission participant. Back on board the Aurora Ascendant, the population's excitement was palpable. In the communal observatory, groups gathered to witness real-time data feeds and visualizations of Titan's evolving surface. Children, born into a future that once only lived in science fiction, marveled at the prospect of a world that might one day resemble a second Earth. Their parents, many of whom were directly involved in the mission's scientific planning, exchanged hopeful glances as they watched the gradual emergence of thawed riverbeds and nascent cloud formations. As the terraforming process advanced, the mission evolved from mere atmospheric manipulation to full-scale planetary engineering. A second wave of payloads, termed the Helicon Array, was readied for deployment. These modular units were larger than their Prometheus predecessors and were capable of more extensive operations. Equipped with massive orbital mirrors, the Helicon arrays were designed to reflect and concentrate sunlight onto specific regions of Titan's surface. By directing additional thermal energy to the coldest areas, the arrays aimed to accelerate the melting process and facilitate the release of trapped volatiles. Each Helicon array was a feat of engineering precision. Spanning 600 meters in diameter when fully deployed, these reflectors were composed of lightweight, adaptive materials that could adjust their curvature to optimize the angle of sunlight. Over the course of several weeks, the arrays unfurled from compact stowage configurations in the Aurora Ascendant, and were positioned into low Titan orbit. With their activation, vast sections of the moon's surface experienced a surge in insolation, triggering a cascade of chemical reactions that further enriched the atmosphere with water vapor and oxygen precursors. Simultaneously, specialized bioreactors initiated the second phase of the terraforming project, biological seeding. These reactors house genetically engineered extremophile microbes, carefully designed to thrive in Titan's frigid, hydrocarbon-rich environment. Once deployed onto the surface, the microbes would metabolize local compounds, gradually transforming the soil and contributing to the slow buildup of organic matter. This biological augmentation was intended to lay the groundwork for the eventual introduction of higher plant life, setting the stage for a fully integrated biosphere. With the preliminary terraforming measures showing promising results, mission planners turned their attention to the next major milestone, establishing a permanent human presence on Titan. The Aurora Ascendant carried within its vast cargo bays a series of modular habitats, each engineered to be self-sustaining and expandable. These habitats, known as the Titan settlements, were designed for rapid deployment and assembly by a combination of human engineers and autonomous robotic systems. On the 18th month of the mission, after months of orbital testing and environmental stabilization, the first Titan settlement modules were released from the Aurora Ascendant via high-precision landing shuttles. As the descent pods pierced Titan's dense atmosphere, the settlement modules, clad in heat-resistant radiation-shielding alloys, began their controlled touchdown on a vast plateau adjacent to one of the thawing river valleys. The landing was executed flawlessly, a choreography of reverse thrust burns, synchronized parachute deployments, and final soft landings cushioned by engineered aerogel pads. Inside each settlement module, life support systems immediately activated. Advanced hydroponic gardens sprang to life, their nutrient-rich solutions circulating through intricate networks of pipes and sensors. Automated manufacturing units assembled additional structural components, while communication arrays established a constant link with the Helios nexus aboard the Aurora Ascendant. The settlers, a carefully selected group of 500 specialists from diverse backgrounds, scientists, engineers, medical professionals, and agricultural experts, stepped out onto Titan's surface clad in pressurized suits. Their first footsteps were recorded and beamed back to Earth, a symbolic moment that echoed humanity's enduring spirit of exploration and adaptation. Under the careful guidance of Mission Control and aided by local robotic laborers, they began constructing a series of interconnected biodomes. These domes were designed to replicate Earth-like conditions, regulated atmospheric pressure, optimal temperatures, and abundant green spaces for both recreation and research. Each biodome was equipped with autonomous climate control systems that could adjust oxygen levels, humidity, and even light intensity according to the needs of the inhabitants. Over time, these domes would merge into a sprawling colony, an engineered oasis on a once inhospitable world. The Titan terraforming mission, however, was not without its formidable challenges. Titan's native environment presented a unique set of obstacles. The dense atmosphere, while an asset in retaining heat, also posed significant challenges for communications and navigation. Radio signals, slowed and distorted by layers of hydrocarbons, required the use of high-frequency laser relays and quantum-entangled communication arrays to maintain contact between the settlements, the Aurora Ascendant, and Earth. Moreover, the chemical complexity of Titan's environment demanded that every intervention be carefully calibrated. Early experiments with the Prometheus units had revealed that a miscalculation in the release of greenhouse gases could lead to localized thermal runaway zones, areas where temperature spikes might destabilize the delicate balance of newly forming ecosystems. To counteract this risk, every terraforming measure was executed incrementally, with constant feedback loops between sensor networks, simulation systems, and human oversight. Each module was designed with an emergency shutdown mechanism, ensuring that if a process went awry, it could be rapidly isolated and corrected. The settlers themselves faced personal challenges. Adapting to the alien landscape meant adjusting to a twilight world with a dim orange glow that replaced the familiar blues and greens of Earth. Titan's gravity, slightly less than Earth's yet still sufficient to impose its own constraints, required new training regimens. Over time, even the human body would adapt, with subtle changes in muscle density and bone structure becoming apparent as colonists settled into their new home. Psychologically, the isolation and remoteness of Titan tested even the most resilient minds. The long communication delay, ranging from 45 to 60 minutes for one-way messages with Earth, meant that the settlers often had to rely on their own judgment without immediate counsel from home. Yet the shared mission and the promise of a fresh start on an alien world forged bonds of camaraderie among the colonists. Social structures were reimagined with community councils, rotating leadership, and innovative conflict resolution strategies emerging organically over the months following the initial settlement. As months turned into years, the terraforming process on Titan entered its next critical phase. The combined effects of the Prometheus reactors, helicon arrays, and biological seeding began to manifest in subtle but undeniable ways. Satellite imaging showed that once frozen riverbeds were now flowing with liquid water, a mixture of melted ices and engineered volatiles. Clouds of water vapor, intermingled with nitrogen and trace oxygen, drifted across the horizon, heralding the onset of a rudimentary hydrological cycle. In the biodomes, the settlers observed the first tentative signs of Earth-like life taking root. Hardy strains of algae, introduced as part of the biological seeding program, flourished under the filtered light that penetrated Titan's murky atmosphere. Experimental plots yielded small but promising harvests of genetically modified wheat and vegetables, tailored to thrive in lower gravity and cooler temperatures. Each breakthrough was celebrated with a mixture of scientific elation and cautious optimism, the understanding that every success brought Titan one step closer to being transformed into a true second home for humanity. At the Helios Nexus aboard the Aurora Ascendant, mission controllers maintained constant vigilance over the evolving planetary system. Advanced simulation chambers projected the long-term outcomes of the terraforming measures, predicting gradual warming trends, shifts in atmospheric pressure, and the eventual stabilization of weather patterns. These projections were critical for planning the next stages of human colonization, the eventual dismantling of some of the artificial infrastructure and the integration of natural processes into Titan's new biosphere. A particularly ambitious experiment involved the deployment of a series of climate sculptors, autonomous drones programmed to modify local weather patterns by releasing precise quantities of aerosols and reactive chemicals. These drones flew in formation above Titan's emerging river valleys, orchestrating controlled precipitation events intended to boost soil moisture and promote the growth of nascent vegetation. The results were nothing short of revolutionary. Within a few months, several regions of Titan began to display a vibrant mosaic of green patches, shimmering blue lakes, and even hints of cloud cover reminiscent of Earth's early morning mist. As Titan's physical environment underwent radical transformation, the human spirit on this remote frontier experienced its own renaissance. In the early days of the colony, art and culture were seen as luxuries. But as the settlers began to feel at home in their biodomes and community centers, they started to cultivate a rich cultural life that reflected both the heritage of Earth and the promise of a new beginning on Titan. Public forums and amphitheaters within the settlement biodomes became venues for poetry readings, musical performances, and scientific symposia that celebrated the achievements of the terraforming mission. Children learned about Earth's history alongside Titan's evolving environment, with interactive holographic libraries and virtual reality archives that preserved the legacy of a planet they had left behind. There was a growing consensus among the settlers that the mission was not only about survival and engineering, but also about creating a society that valued creativity, innovation, and a deep connection to both science and art. Local traditions began to emerge, annual festivals commemorating the first landing, the symbolic Day of Thaw celebrating the moment when Titan's surface first yielded to warmth, and the Aurora Ball, a celebration of the stars and the cosmos that connected Titan back to Earth. These cultural practices served to strengthen communal bonds and instill in every colonist a sense of purpose and belonging. The settlers, once strangers to one another, were now united by a shared destiny on an alien world. Even as the technological marvels of terraforming reshaped Titan's physical landscape, subtle changes were also taking place within the human bodies and minds of the colonists. To ensure that these changes did not compromise health or performance, the colony established a comprehensive medical monitoring system. The transformation was not solely physical. In quiet moments within the biodomes, amid the hum of life support systems and the distant echo of robotic laborers, it was not unusual to hear settlers reflecting on humanity's journey from a fragile species on a blue planet to pioneers of interplanetary transformation. As the mission entered its second decade, Titan's metamorphosis became increasingly evident. In a grand ceremony held at the main settlement's central dome, the colony's leaders announced the official commencement of the dawn phase of Titan terraforming. The center, named Nova Aetas, Latin for New Age, was to be a living museum of the transformation, a place where the story of Titan's rebirth would be chronicled for future colonists and the descendants of those who had dared to dream. With a communication delay of only minutes compared to the earlier years of the mission, the colony re-established a more interactive dialogue with Earth's scientific and cultural institutions. Earth had changed too during the decades since the launch of the Aurora Ascendant. Every message received by the colonists was a bridge, a symbolic reminder that no matter how far they ventured, the legacy of Earth was interwoven with the destiny of Titan. In turn, every data packet transmitted from Titan to Earth carried the promise of renewal, of a world reborn through the combined might of human intellect and nature's inexorable drive to evolve. Now, as the mission approaches its 15th year, the focus shifts toward ensuring that Titan will eventually become a stable, self-sustaining biosphere. Long-term projections by the Helios Nexus indicate that within the next decade, Titan's atmosphere will reach a composition conducive to human habitation without the need for pressurized domes. The final phase of the terraforming process involves a series of delicate maneuvers, gradually reducing the reliance on artificial heating and reflective arrays while increasing the capacity of natural processes, photosynthesis by engineered algae, the water cycle initiated by the thawed lakes, and the gradual accumulation of oxygen produced by bioreactors. In this final stage, the role of the colonists will evolve from that of active terraformer to stewards of a burgeoning ecosystem. New generations born and raised on Titan will receive comprehensive education on planetary sciences, sustainable living, and the history of the mission. These children, with eyes wide open to the wonders of an alien sunrise, will learn to read the subtle changes in Titan's climate, to understand the delicate interplay between technology and nature, and to cherish the fragile balance that sustains their world. The Aurora Ascendant, now orbiting high above the transforming surface, remains an ever-watchful guardian. Its sensors and communication arrays continue to feed real-time data into the central repository, allowing both colonists and Earth-based researchers to monitor every nuance of Titan's evolution. The vessel, having fulfilled its primary role as the harbinger of change, now stands as a symbol of human resilience and ingenuity, a reminder that even the coldest, most distant corners of our solar system can be warmed by the light of hope and determination. As twilight descends over the newly transformed landscapes of Titan, a hush falls over the colony. The stars, once distant and cold, now shine with the promise of a new era, a future where humanity has not only survived but thrived on a world that was once deemed uninhabitable. The Titan terraforming mission of 2085 has become more than a technical endeavor. It is a living narrative of transformation, sacrifice, and the indomitable spirit of exploration. In quiet moments, as colonists gaze out from the curved windows of their biodomes, they see the distant glimmer of Saturn and the swirling rings that have long been a source of cosmic mystery. They recall the days when Earth was their only home, and yet they also recognize that the journey from the familiar to the extraordinary has been paved by countless acts of courage, scientific brilliance, and an unwavering belief in the future. The legacy of the Titan terraforming mission is etched not only in the altered geology and nascent ecosystems of a once frozen moon, but also in the hearts and minds of those who dared to dream of a second home. It is a legacy of innovation, where every carefully executed maneuver, from the initial launch of the Aurora Ascendant to the final delicate adjustments in Titan's atmospheric composition, speaks to the power of collective vision and the relentless pursuit of a better tomorrow. In the coming decades, as Titan gradually sheds the vestiges of its old identity and embraces a new, vibrant existence, the lessons learned from this monumental project will guide future generations in their endeavors to shape worlds beyond our own. The story of Titan is a story of transformation in every sense, a reminder that with vision, determination, and a commitment to scientific excellence, even the most seemingly insurmountable challenges can be overcome. And so, as the colony of Titan enters a period of peaceful equilibrium, the colonists prepare to record the next chapter in the annals of human achievement. They document every phase of the transformation, every scientific breakthrough, and every personal triumph. From the first flicker of artificial warmth to the eventual awakening of natural life, the Titan terraforming mission stands as a beacon of hope for all who look to the stars. It is a story of redemption, a reminder that our species, forged in the crucible of Earth's challenges, can rise to meet the demands of the cosmos. In the silent majesty of Titan's transformed landscapes, one can almost hear the echoes of countless voices, each whispering that life, in all its wondrous forms, will always find a way. As the mission's final phase unfolds and Titan's atmosphere settles into a stable, life-supporting equilibrium, the colonists celebrate with a grand ceremony under the vast starlit sky. The symbolic day of Aurora marks the moment when the last vestiges of artificial intervention are gently phased out, leaving behind a self-regulating, thriving ecosystem. In that moment, the line between engineered transformation and natural evolution blurs, and Titan becomes not merely a product of human intervention, but a living world in its own right. The Aurora Ascendant continues to orbit silently overhead, a timeless sentinel bearing witness to the achievements of those who dared to dream. Its legacy, enshrined in the data logs, archived images, and heartfelt messages transmitted back to Earth, will forever remind future generations that the spirit of exploration is as infinite as the universe itself. In the years to come, as Titan's transformed surface welcomes explorers, researchers, and settlers from all corners of the solar system, the story of the Titan terraforming mission will be told and retold. It will be a narrative of hope, of perseverance, and of the realization that humanity's destiny is not confined to the pale blue dot we once called home. Rather, it is a destiny written among the stars, a legacy that will inspire not just the colonists of Titan, but all who look upward with wonder. Thus, as the sun sets over the new horizon of Titan and the colony gathers to celebrate a milestone in their shared journey, a collective thought resonates. Earth may have been the beginning, but Titan is now the future. And in that future, every challenge overcome, every scientific mystery unraveled, and every life nurtured is a testament to the indomitable will of humankind. This is the story of the Titan terraforming mission of 2085, a story of ambition, resilience, and the transformative power of human ingenuity. It is a story that will continue to unfold, written by the hands of those brave enough to shape a new world, a story that echoes across time and space, reminding us all that the frontier of possibility is as boundless as the cosmos itself.